Hello and welcome to episode 25. So we are going to start classes and objects. You might have heard the term object-oriented programming language, and Python is an object-oriented programming language. So what that means is that almost everything in Python is an object with its properties and its methods. So any of this stuff we've gone over, like lists, sets, dictionaries, all of that stuff is an object. So a class is like an object constructor, or think of it kind of like a blueprint that creates objects. So we can create a class by just using the keyword class here, and then we can just say new class, and then we can just give that class some kind of a quality. So we can assign a variable to it, like x equals 5. Now we can create an object out of that class, so we can make our new class, we'll just call it the word 1, and we will have it equal new class, and we will execute that. And then we're able to print 1, and then we're calling the x variable from 1, from the object that is 1. So here if we open our terminal and we do py25.py, you'll see that we're getting the number 5 back from x by printing 1.x. And this is also called dot notation. So obviously that's not very useful when we could just print x if we want the number 5 to come out. So what we really need to cover is the init function. So instead of having a class or an object in their simplest form, we have to understand the built-in init function. So all classes have this function, and it's a dunder function, so it looks like this, as we've kind of gone over before. So you'll have this init function. Classes get this when they're being initiated, and you can use that init function to assign values to object properties or other operations that are necessary to do when the object is being created. So the best way to do this is obviously to just show you. So we'll come up with a class. We'll just make it a person class here, and then we can define the dunder init here. And inside of this, we can put self, name, age, something like that. And you can put self.name and assign that to name. And then you can say self.age equal to age. And I know that this looks kind of strange, but you'll understand kind of how it's getting put in as arguments to that object as we're using this. Because remember, this is a blueprint. So when we initiate a new object out of this, when we make an object from this blueprint, we're going to pass in arguments, and the arguments we're going to pass in are name and age, and it will assign those to that object with this self.age and self.name, and that way we can make objects from this exact same blueprint that have different values. So for instance, we could have 2 people here, and we'll just call like P1, and we'll just pass in person because that's our blueprint, and inside of this we'll just pass in a name and an age. So we'll name him Bob, and Bob will be 21. And then we can have person 2 here, and that can use the same blueprint, and we can name them Dale, and Dale can be 18, and then we can print both their names and ages, and just kind of see. I'm just copy pasting for simplicity's sake, although VS Code makes that hard sometimes. So there we go, we save, we run, and you see that we're getting the different values even though we use the same blueprint, because as this constructs each object, it's assigning the passed in values to that specific object. It's not just pointing everything back to person. It's not assigning it to the class person. And that's why that self.name and self.age is necessary. And just so you're aware, the reason that this is inside this init function is that's called every time we create an object. So right here when we create the object using the blueprint, we're calling this blueprint person. We're passing in name and age. And self, we don't need to declare. It's just using that as an argument for this init function. And it's just saying assign these variables, and name, this name variable goes down to here. So it's applying this value to what we're calling self.name. So we could change this to whatever, and whatever is up here has to match what we're putting down here, but this naming makes sense. Now to just further elaborate on this, we can also add our own object methods. So there are functions that belong to that object. So we'll just create a method in the person class, and this will just be kind of like the name and age, where it will be specific to that object from the blueprint. So we'll just say greeting here. We'll have it apply to self, and we'll just have it print. And then we'll do self.name, and we'll save that. And then we don't really need to do person2 anymore. And then we can just call that function on P1. We execute that function, save, come down here, print, and you see that we didn't have to write print in here because print is here. So we're calling that function on P1, which is the object we made with this blueprint, and this blueprint has the greeting function built into it. And just remember that it applies it, the blueprint would apply it to whatever object we create with it. So if we did create a P2, it would have a different name and everything like that. And just remember that the self in here, that's just that parameter is just a reference to the current instance of the class. So not the blueprint itself, just the instance, which is the object that we made. And that's how we are able to access those variables that belong to that class. And just so you know, the self parameter, you don't have to call it self. You can just call it whatever you want. It just has to match, and it has to be the first parameter that you pass in of any function in the class. So just make sure you're passing it in. So we could rename it here to S, which obviously isn't very intuitive unless you're familiar with all of this stuff. And then it's still going to function fine, as you can see. And we can do the same thing with name here. Just know, like, if we're passing in here, we want to make sure that we're setting it like that. So s.in equals in, because that's the parameter we're passing in. And we're saying that when we pass that in, apply it to the self.name. But obviously it's just in. And we can do that here. Save. And I'm getting an error because I forgot about this part right here. So we want to make sure that we change all names to in before we run it, and then you see it still runs fine. So just I leave the bugs in just to show you I make mistakes plenty of times, and it shows you right where it is. It said line 23, so I just came here and saw line 23. However, we will undo all of those changes so that it makes more sense. And I would recommend naming everything something that makes sense, so that when other people have to read your code, or you have to go back and read your code, which I've done several times, you know what you're talking about. Just really quick, I want to print just P1. And never be afraid to mess around with stuff either, because you will learn a lot. So you can see that this is like the dunder main.person object, right? So we're not saying the age or name anymore, or anything that's inside of it. And again, we have something like age here, and we're able to change that or modify it. So we can take like p1.age here, and we could set it to, what do we have it set to? 21. So we'll just set it to 500 for simplicity's sake. Save, and you see that we're modifying it after we've already built the object. So we have access to any variables or properties inside of the object, and we're able to modify them. We could also delete it if we wanted. We could do something just like get rid of this. We'll just actually comment that out. And then you could do something like delete, which is just del again, and p1.age. We save, run it, and you'll see that we get the error because we deleted that attribute entirely. If you wanted to delete the entire object, you could just get rid of the .age, save, run it, and you see that P1 itself is not defined. Not P1.age, but P1 itself has been deleted. So we deleted the entire object. We've seen this next thing several times, so we'll just get rid of that really quick. So if you have a class, we'll just make a new one. make self, whatever. We don't actually pass anything in. Let's just do this. And then, so you can't have an empty class. So if we have class fake here, and then we try to substantiate, you see we're getting the red bar. So if we try to do anything where we assign it like f1 equals, fake, and we try to call it, this isn't going to work because it thinks we're inside this class here. If you ever have a reason to have an empty class, just remember you can use the pass statement, just like we've seen before several times. And then your program will still run. We're not getting any errors with class fake. If we take out pass and we save, obviously we're going to get an error. So you can see expected and indented block, which we've seen that error before. And that just means that we don't have anything inside of the class. All right, as usual, w3schools.com has exercises you can do to practice any of this stuff. And we will be moving on to inheritance in episode 26.